All right, welcome back. And then today we are going to do another tree problem. This one is the invert binary tree. So very similar like the previous one I did, which was maximum depth of binary tree. It doesn't seem as obvious, this one, but you'll see we'll be using the same techniques. Now here, the explanation is really simple, inverted binary tree. So now if you look at this tree, the output would be that. And it's the reason why I like this one is because it was popular because of Max Howell. Because apparently he said that he made homebrew, which a lot of people use. Almost everyone uses it because homebrew is basically like the Apple's, the MacBook Pros are like the Apple's like repository management. Like you could just, it's kind of like wait, let me think. It's kind of like NPM, but for Macs. All right, cool. So he made that, but apparently because he couldn't invert a binary tree on a whiteboard, he didn't get the job at Google. So that was pretty funny. Anyways, so let's do this problem. Let's go to the iPad and let's write out this tree 4, 2, 7, 1, 3, 6, 9. So we want to invert it, okay? We want to make sure that this becomes 4, 7, 2, 9, 6, 3, 1. So how do we invert a tree? So when you think about it is, okay, let's see. Imagine I am the head. What if I just switch these two parts? Would that be inverted? Like we want to get to here as the end state. This is the end state that we want to get to. And now let's just play with the tree a little bit. Like whenever you're interviewing, you should just play with the idea, with the data structure, with the question a little bit. So you're thinking, okay, what if I just change left tree and right subtree together? What would that look like? It's gonna look like this. 2, 1, 3. All right, so is this the same as that? No, not yet. So these guys are good because we inverted them, but then their children are in the wrong place. They are not inverted. Okay, so what if you invert these guys too? Okay, so imagine, so what if every subtree I start to invert these guys too? So this becomes 9, 6, 3, 1. So we're gonna invert these subtrees. I'm gonna put it blue, like these guys. I'm inverting the subtrees. So that seems to work. So now these two guys, they are similar. They are the same. So it seems like just from this example that we just need to invert the left and right children, and then their own children, we should invert them too. So maybe it sounds like we have to recursively invert all of the children. Let's just double check. Let's do a size 4, like a tree of size 4, depth 4. Let's just add one guy here, one guy here. Oops, let's just make a different number. Let's do, what number should we get? 1, 2, 3, 4. We haven't done 5, 6, 7, 8. Okay, so imagine we've inverted all of them. And then at the end, if we do not invert these guys, then it wouldn't work, right? Okay, so it seems like we do have to invert all of them. So we're gonna do the same thing here, and then we're gonna apply all of these inversions, and what it'll look like is it'll look like this. Wait, what am I doing? Oh, oops. The numbers I want was the original 1, 2, 7, 1, 3, 6, 9. And then if we apply everything we did here onto this one, it'll look like this. 9, 6, 3, 1, and then 3 would have 5 and 8. Okay, so then these guys will not be inverted. But we do want them to be inverted because that would be the correct one. Because like here, as you can see, they're not inverted. It's 5, 8, and then here's also 5, 8. These guys should be inverted. All right, so we're pretty sure that what you have to do is you have to invert your left and right. So you just switch their places. and then also their children, you should switch those places. So that sounds like recursion. I want to invert everything on my left children. I want to invert everything, or more like I want to invert tree on my left subtree. I want to invert tree on my left right subtree, and then just swap their position. And then that's what I have to do, like me as the node. So let's just write that down. All right, base case. What is the base case? Remember, we're doing recursion. We always have a base case. If there's nothing, then we return, nothing. Actually, that's pretty funny. I return, because it's nothing, when you return the root, it's going to be nothing anyways. So yeah, and then else, what do you want to do? You want to call invert tree on the right, invert tree on the left, right? So pretty simple. Let's say right equals self invert tree. Oh wait, let's see. Does it return anything, this function? Am I supposed to return anything? Class invert tree. Okay, it's supposed to return a tree. Okay, cool. So self invert trees, root right left equals self invert tree root left. Right, so now you have the right and the left one. So then what you want to do is you want your own tree, which is root right, to be left, and then root left equals right. And then you just return root. Let's see if that works. Okay, that seems to work. If you submit, yep, and then that's pretty much it. So that's how you do it. And yeah, that's inverting tree. Now you could also do it by iteratively. If you want to learn how to do that, you could look at my previous one, maximum depth of binary tree. I teach you and give you an intuition on how to turn recursion into iteration. So make sure to check that out. Oh, now if you think about the time complexity, what is the time complexity for this? Yep, think about it. Yeah, it's pretty much the same thing as O of n. Yeah, because you have to go through all the nodes. You're going to be swapping through them anyways. And then also in terms of the space complexity, same thing as maximum depth binary tree, where it's O of log n if it's O of log n if it's balanced, the tree, or it can be O of n if the tree is not balanced, if it's a straight twig. Yeah, so that's pretty much it. And yeah, see you on the next one.